Alright, in this video I'm going to talk you through the basics behind exponential growth and decay. Specifically, the different types of functions you can see that are exponential growth and decay. So these functions mostly come in three forms primarily. So I'm going to talk through each of them. So this first one we have y equals a times b to the x. The reason that makes it exponential, notice our variable x is in the exponent spot. So that is what's going to change, where these other pieces typically stay the same. So some things that we can notice with this equation is we have an a, b, x there. A, in cases, is your initial amount. That's always what you're starting with. It's your initial amount, whatever you begin with. On the other hand, we have this b here, which is your growth, or it can be your decay factor. So we have initial amount A and we have a growth or a decay factor. So a lot of questions, they'll give you an equation with A and B filled in and they'll ask you, is this exponential growth or decay? There's various ways you can go about doing it. If you completely forget, one of the easiest ways I think of doing it is use your graphing calculator. Whatever the equation is, plug it into your calculator and you're going to get one of two graphs. So you have your XY plane. You're going to have a graph that when you look at it going from left to right, you're going to notice it starts small and goes up big. And then you have ones that start big and go small. So the way I read these is I read from left to right. So this left one, you can get an equation that starts left small and then we take off, we get big. That is going to be your growth. And then over here, reading from left to right, you're going to start big and get small. That more resembles a decay. So you can look at it that way graphically and know growth or decay. Another way we can know is it has to deal with B. If you want a growth, the value for B is always going to be greater than 1. So those numbers are like 2, 3, 4, 5, 6. So when you think about, taking your height and multiplying it by 2 or 3, you're going to notice it gets bigger or it grows. So numbers bigger than 1, that represents growth for B. We could also have decay. B on those numbers is going to be between 0 and 1. So numbers like that can be like a half. So if you take your height, multiply it by a half, so I'm 6'6", I'm now 3'3". So I've gotten a lot smaller, I decayed my height. So that's one way of looking at growth and decay. The other two equations we have y equals a times 1 plus r to the t. Very similar to the first equation, a is still going to be your initial amount. That is going to stay the same, and that's going to stay the same for this one over here. A is still our initial amount. And that is always whatever you start with, you begin with. The only other differences here is we have these variables r and t, which don't really change things a whole lot. R is going to be your rate, so your rate of growth or decay. So R is our growth or decay rate, and typically that's some sort of percentage. The other new piece is T, which most people can remember from other problems in math, that T is going to represent time. How long are we going to grow or decay? So then the question is these two equations very similar, but which one represents growth and which one represents decay? Well, all it takes is just a grasp of what does it mean to grow and what does it mean to decay. Well, when something grows, you typically get bigger, so you keep adding to it. So that's going to make this our growth. And over here, when you have subtraction, that's going to take away from something and make it smaller. So that's going to be our decay. So both equations are very, very similar. The way you know, well, which one's growth and which one's decay, it always has to do with the plus or the minus. Growing, we're adding. Decaying, we're going to subtract. So growth and decay. And that is exponential growth and decay basics.